There are two ways to change relative humidity. One is to change specific humidity, the actual amount of water in the air. The other is to change air temperature. Rule number two. Let's face it, if there's a rule number one, there has to be a rule number two, right? Because otherwise, rule number one would just be the rule. But that's not what it is. Rule number two is this. If there is a fixed amount of water vapor in the air, that means the specific humidity, the mixing ratio, is not changing. It's staying the same. Then, as air temperature rises, relative humidity decreases. And as air temperature decreases, relative humidity rises. This is called an inverse relationship. Very good. One thing's going up, the other thing's going down. What time of the day do you tend to find dew on your car? Think about that. What time of the day does that happen? Morning, of course. It's cooler in the morning. Do you find dew on your car in the afternoon? I don't think in my lifetime I've ever had dew on my car in the afternoon. Why? It's warmer. This is a relationship of temperature. Take a look at this graph on the right-hand side. This is a 24-hour graph from 12 a.m. to 12 a.m. with noon in the middle. Notice air temperature is graphed with the dotted line. Relative humidity is graphed with the straight line. And if you look at this carefully, you can see the inverse relationship. As air temperature is going down, which is happening throughout the night, you can see that relative humidity is rising. Then when the sun comes up and air temperature begins to go up, relative humidity decreases. There you go. So when is relative humidity likely to be the highest? It's likely to be the highest when air temperature is at the coldest, which is generally the earliest part of the morning before sunrise. When is relative humidity likely to be the lowest? When air temperature is at the highest in the afternoon. There you go. If you do have dew on your car, what happened was the air temperature dropped down to what's known as the dew point temperature. The dew point temperature is the temperature at which an air mass becomes saturated. In other words, the relative humidity is 100%. So the proverbial atmospheric glass is full. And at that point, water's going to come out. And that means, in the case of the atmosphere, either condensation, which means that the water's going to go from a gas to a liquid, or sublimation, also known as deposition, which means that the water's going to go from a gas to a solid. This is, again, contingent upon temperature. If the dew point temperature is above 32 degrees Fahrenheit, condensation will occur. If it's 32 degrees or lower, in general, sublimation will occur. Okay, I am using the word temperature. Most of you understand what the word temperature means, at least from one context. So what is the difference between air temperature and dew point temperature? Air temperature is the energy contained in the atmospheric molecules. In other words, when you walk outside from inside your house, what do you feel in the air? You are feeling the air temperature, whether you feel warm or cold, or hot or cold or cool or whatever it may be. Dew point temperature is a description of the water vapor in the air, and it's directly linked to specific humidity and mixing ratio. Okay, condensation means the water's going to go from a gas to a liquid. There are many forms of this, but for us today, we're only looking really at two things. Dew, which is condensation onto the surface of an object that is dropped below the dew point temperature. So in other words, the object is below this magic number that is a dew point temperature. And fog, which is a mass of suspended water droplets that forms a cloud that's in contact with the ground. So all fog is a cloud that's touching the ground. When it's up in the air, we call it a cloud. When it's down on the ground, we call it a fog. Take a look at this little diagram I created for you. Notice on the left-hand side, we have dew point temperature, and it says 55 degrees, the blue line. On the right-hand side, we have air temperature. It's 75 degrees, the red line. Notice they are not the same number. As long as they are not the same number, the relative humidity is going to be less than 100%. Once the relative humidity is 100%, we can say the air is saturated, and at that point, water is going to come out in some form. So let's assume this. Let's assume the air temperature begins to drop, which is really what this particular part of the lesson is about. As air temperature drops, notice it goes from 75 to 70, then down to 65 degrees, then to 60 degrees, and boom. At that point, the air temperature and the dew point temperature are the same number, in this case, 55 degrees. At that point, we can also say the relative humidity is 100% and the air is saturated. Those three things always go together. Relative humidity 100%, air saturated, air temperature and dew point temperature being the same number. They always go together. And when that happens, either condensation or sublimation, also known as deposition, will occur.